Hey everybody, today we'll do another video, and today I will continue on few problems on multivariable calculus, which is calculus 3. I will do some more vectors, and that's it. That will be for this section, I think. Because the other one said, some of these problems said using the graphic calculator, and I don't need to teach you how to use the graphic calculator. It would be a separate video on that. Some of the problems that using the graphing utility. But anyway, that I will do. We'll find the magnitude of the vector, and it says find the magnitude of vector v, like that, right? So basically, find the magnitude of the vector. And the problem is given in the form of 3j and 5k. So vector v is 3j minus 5k. Okay, so now this is given, right? In last video, I already went through that when you have a terms like that, about 2 videos, I guess. So when you have a 2 letters like that, we should replace the same by, if you have the value of j and k, we can replace this. We're missing I here. See that? We're missing I. So technically it should be I, j, and k, right? So we have a j and k, but we're missing I, so we need to add a 0. So here we need to add a 0. Technically this is not important right now to take the magnitude, but if you need to graph it, you need to consider that this will be 0, 3, negative 5. That would be the value for that. Why? Because we're missing I, j, k. So we're missing I, so that's why we put 0, 3, 0. So is it 0, 3, and 5, right? So that's how we read that. Okay. So so we do that, right? So we need to actually take the magnitude of this vector, and we say last time that the magnitude of the vector is found by the magnitude of the vector is found by the value that is given in under the square root, right? So the magnitude is going to be, in this case, is going to be v like that with a 2 part, and that is going to be equal to the value of v1 square plus v2 square plus v1, v2, and v3 square, right? Something like that, right? So what happened here is that when we do this, we actually find the magnitude of the vector, right? Which is technically, they call the length, right? Length, magnitude, pretty much the same thing. So this is also called the length, right? Length and this pretty much the same. Okay, so so in this case, to find the magnitude of this, right? So it is given, right? So this is given. This is actually problem 81. So So if this is given, then we have to extract the coefficient. And when I extract the coefficient of this, it's going to be 3, comma, negative 5, comma, actually no. it's going to be, it's going to be 0, comma, 3, comma, negative 5, right? Because we're missing I. So again, technically, you don't have to do this, but it's good. It's good for learning purposes because when you're dealing with this, we know that we're dealing with three-dimensional. So this is X, Y, Z, right? So, so basically, that's how we do it, right? So now, if we do this, we follow the formula that I had before in there, right? So take the magnitude of this, which is equal to the square root of what? The square root of every single piece of this is square, right? So it's going to be what? It's going to be 0 squared plus 3 squared plus minus 5 squared, which is going to be the magnitude of V, which is going to be what? It's going to be what? This, I don't worry about that. I just put that right there just to have, you know, something to fill up the space because I am dealing with three-dimensional. So it's, I mean, it's a good, I guess, a good practice to put it over there, right? So this would be, if I square this, I know that it's 0, so I cannot not even bother in writing this over here, but I will write that. That would be 9. When I square negative times a negative, give me a positive, so that would be 25. And then if I add those together in there, right? So that would be the square root of 34, right? And that's it. This cannot be, I mean, it can be reduced, but I cannot take the square root. I can factor that by 2. And it doesn't really help any. If I factor out, pull 17 out of it, right? So it will be 2 times 17, but I cannot take the square root of 17, so therefore I leave it like that. So that is for number 81, right? Now let's do 83 using the same technique. So, so the same thing, we find the magnitude of the vector in 83 is 83. In 83, I got an I got minus 2j minus 2j, and I think I got a minus 3k. Okay, notice that now I have an I. See? Now I have an I here. Before I didn't have that. So when I extract the coefficients in this is number 83 in the same book that I am using. If you have the same book, I mean, you can follow. If you don't have that book, well, you know, just follow something that is similar, right? So, so in this case, what I do? Well, do the following. So take the magnitude, right, of that, which is going to be equal to. Before that, it's a good idea to take the coefficients out of this, right? So, which in this case is what? I is 1, is 1 here, right? So 1, 1, and then here's a minus 2, and here is a minus 3, right? Okay, so yeah, so that's how you do it. Now what I do here is the following. So in this case, right? So I do this, right? So I do this and put it right there, which is 1. So I put the 1, squared plus negative 2 squared plus negative 3 squared, right? So then vector v, the magnitude of that is equal to 1 plus 4 plus 9. So this is actually uh, 14, right? So we'll get the square root of 14, right? After I add those up, is actually the square root of 14, right? So that is in that one. So that is that one. So they only want the magnitude. So that's it. So that's number 83, right? Now, last time I showed you guys how to do the unit vector, right? And the unit vector is what? We say that some vector u, right, is equal to 1 over the magnitude of v, right? Multiply that by b1, comma, b2, comma, b3, so forth, right? You gotta, kind of work with me because I got some congestion going on. I don't know what it is. It might be the China virus, maybe. I don't know. I call it China virus every once in a while. So okay, but this is. I don't think it's the China virus because I already had it, and I also, yeah. So I hope it's not it. I mean, I've been like this for a few days already. But anyway, this is this is how we do the vector, right? Unit vector. U. The book usually kind of do it like a bowl, something like that. Like this is not working good, but the book technically specified this as like kind of bowl type of U that represent the vector, right? So, all right. So it is a vector u, right? So vector u is equal to 1 over the magnitude, which means that we take the magnitude and we multiply each component by that. Sometimes these components can be reduced if you have a fraction. Sometimes you can not reduce it, right? Anyway, let's do this. So this is problem 85. And problem 85 is given to us as I say the vector v. Vector v is equal to vector v is equal to 2 minus 1, 2 comma negative 1 and 2. 2 comma negative 1 comma 2. Right? Step 1, we taking the magnitude. So the step 1 will be taking the magnitude of that, which is equal to 2 squared plus a minus, right? Plus a minus 1 squared plus a 2 squared. When I take the magnitude of that, right? So, and when I square that and take the magnitude, this is equal to 4 plus 1 plus 4, right? Which is basically, 9, right? So this will be 9, right? But then we do this over 1, right? Over 1, this will be over 1. That would be actually That would be over 1, over 1, and that would be over 1, right? So over 1 is, of course, over 1. Now we're taking the square root of this, which is equal to what? It's equal to 1 over 3, right? So that's it for this part. But now we have to consider this, right? So this is the unit vector. This is basically find the unit vector, right? And so when I take this number and put it here, right? And then I got to replace every value that I have over here, right? In this case, I got 2, negative 1, and 2. So the answer will be what? Will be 1 over 3. But the parenthesis is going to be 2, comma, 1, comma, 2. Negative 1, comma 2, right? Okay, so that's how we do that. That is number 85. Then we do number 87, which is similar. Oh, but before that, they want us to do it the opposite direction, right? Okay, so they want us to do the opposite direction, right? So this is part A, right? This is part A. B, they want us to do the opposite direction. B, right? Opposite direction. Direction of V, right? That's what they want. Which means I have to add only on the magnitude of the vector. I have to pull out a negative, right? Because remember, if the vector is going like that, it's a negative. It's a positive, right? Or if the vector is going like this, it's a negative. So all I gotta do is switch the direction of this to make it what they're looking for, right? So in this case, this one would be just this would be another copy of that with a negative sign in front of it. Would be, this is part A. All right, so I already had it right there. So okay, so never mind. Then part B is going to be 1, negative 1 over 3, 2, comma, negative 1, comma 2. See, I just add a negative sign in front of it, and that is the solution for this in the opposite direction, right? Okay, so that is the solution for 85. So let's do 87 real quick. Okay, so 87, I have a 3 still. 87, the same thing, right? It says find the unit vector of vector V, and do the opposite, right? That's part 8, right? Part 8. B, opposite direction, right? Opposite direction of vector of vector v, right? So which means just switch, right? Just revert the sign or whatever the magnitude is. Okay, so in this case, v is equal to 3 comma 2 comma -5. So now the magnitude of that is equal to 1 over the square root of, again, v1 squared plus v2 squared. You can actually do it without a parenthesis. I mean, v2 squared plus v3 squared. And again, we are assuming that the value of this given, this is the value that is given. We are assuming that the other value is 0. But let's say, for example, that they say that one point is a vector. One point of the coordinate is, maybe comma, maybe 3, comma 0, comma 1. Then you have to do the vector component. But in this case, we are assuming that the origin is sitting at the origin. This vector is sitting at the origin, which is 0, comma 0, which is, again, this is x, y, z. Okay, so in this case, we will follow this formula, right? So we follow the formula, and then we do what? We do, this is going to be equal to this, right? So this is 3 squared plus 2 squared plus a minus 5 plus a minus 5 squared, which is equal to the vector v. And I square that, and also remember this is over 1, so put that over 1, right? And then remember that we have over here v1, okay, comma v2, comma v3, right? So we taking the magnitude of this, then we replacing the value of this into that, and that will be our answer, right? So in this case, we actually doing this, right? So we doing this. So we take the magnitude at the bottom, right? So it's going to be 9 plus 4 plus 25, right? So in this case, put over 1, right? So in this case, this will be 13, right? This will be 13. 13 plus 25 will be 38. That's what I think it is, right? 38, right? So now this is the magnitude, right? So now what happened here, I need to put this this in front of this, right? So the answer for 87 would be this in front of this, which is going to be, I cannot take the square root of that, so we just leave it as it is. I mean, I can, but it's going to be a decimal, so might as well just leave it as it is. So it's going to be square root of 38 times what? Times the value, right? Times each value. Just hope I copied this correctly. Yep. So it's going to be the value of those numbers going to be 3, comma, 3, comma, 2, comma, -5. Value for part 8, right? Part B is going to be 1 over the square root of 1 over the square root of give me 1 second. It seems like the computer is going down. So, so here, so it's 38, right? And then here, basically, it's just 3, 3, 2, 5 with a negative in front of it, right? So that's B. That's part B. All right. So again, that's the answer for that. So just reverse the sign. This is a negative. This is a positive. Why? Because again, considering the vector, like that. That's a positive, and that's a negative. Just the opposite, right? So, assuming that this is y, this is x, this is y, right? And you got this is positive vector, this is a negative vector, right? Okay. So that's it for today. On the next video, probably I will be doing some just starting on the vector, on the vector product, on the dot product. Yeah, dot product. Yeah, that one is, yeah, next section. Okay, so I hope you like this video. If you do, just give me a like, share, and subscribe. Thank you for watching.